Hello, welcome to Weather Lab 1, video part 2. We're starting with question 7, which is just taking a look at, first off, the paragraph prior to, talks about changing temperature with height. As you increase in altitude in our atmosphere, you decrease in temperature up to a certain point where we actually pause and the composition of the material in the atmosphere begins to have a lot of what we call greenhouse gases. These are things like ozone and water and carbon dioxide and nitrous oxide, materials such as that. And so they kind of settled in this secondary layer, and this stuff really absorbs a lot of sunlight. And that means that it warms up pretty rapidly. And so this layer, the stratosphere, temperature actually warms with increasing altitude. Now the density once again settles out. We go back to having a lot more nitrogen and oxygen again in the atmosphere. And at this point, temperature does what it does down in the troposphere, which is that it cools with increasing altitude. From there, we hit a point of pause. And this is where things get funny. This last little bit is incredibly warm when there is an air molecule present, but the air molecules are very sparse. A lot of them are ionic, meaning that they're missing some electrons, making them lighter weight, and therefore having charges, which is also why they react to particles coming in from space and make beautiful things like the northern lights happen. And so these are highly, highly energetic air molecules that are very, very sparse, very spread out, and they warm up exponentially. They get up into the thousands of degrees Celsius, so they're really warm, and this layer is the thermosphere. There's this natural cooling off, warming up, cooling off, warming up, and where they do that is where we draw the line for each layer. So this is one way that we could divide up the atmosphere based on temperature. So question 7, ozone is a good absorber of ultraviolet radiation from the sun. How does the highest concentrations at 20 to 30 kilometers influence the atmospheric lapse rate? So if we look at between 20, I'm not going to draw a straight line, sorry, and 30, what is it doing right in there that is influencing? And this should be like a go figure because I just told you the answer. So write that down, nice complete sentence. So now, moving towards question number 8 and just pointing out this nice little fact in here. It basically says air temperature at 15 degrees Celsius on Earth's surface, that's the Earth's surface temperature average, decreases at 6.5 degrees Celsius every 1 kilometer. So every 1 kilometer that you go up, it gets 6.5 degrees colder. This little fact here is called the environmental lapse rate, or ELR. You should put this in your hard notes, like your class notes, because environmental lapse rate will come up again and again and again, where we will say 1 kilometer, we'll see a temperature decrease of 6.5 degrees Celsius. This is the norm. So now, knowing that fact, question 8 asks you to fill out the table. And so you're going to go over to the second page here. This is page number 5, and you're going to fill out the table. So if you're at 8.5 degrees Celsius, you're going to cool off at 6.5 degrees every 1 kilometer. So the jump between 1,000 meters, because this is in meters, so every 1,000 meters is 1 kilometer, to 2,000 meters is a jump of 6.5 degrees Celsius. So you will subtract 6.5 from 8. Sorry, not 8, 8.5, but 8.5. So you subtract 8.5 minus 6.5 gives me 2 degrees Celsius. This next part, I'm going to do the same thing, except for I'm going to use the 2 degrees Celsius, and I'm going to notice that I'm going from 2,000 to 4,000 kilometers. So this is a jump of 2 kilometers, which means it's 6.5 minus 6.5 again, so that's going to be subtracting 13, right? 13 degrees. So it's going to be 2 minus 13 degrees. And that'll give me negative 11 degrees. The next one, I'm going to see that I'm jumping from 4,000 to 6,000, so 4 to 6. So that's going to be 13 degrees again. Negative 11 minus 13 degrees is going to be a negative number again. So I'm going down 13 degrees, and I'm going to get 24 degrees, and that's a negative number. And it should be getting colder, so I'm going to keep working that. So you guys finish up the last two, and then you will move on to the next set of questions. So now my next set of questions, question 9, asks me to plot my 3 lines. They ask you to plot atmospheric standard, which is the one that we were doing the subtracting numbers for. They ask you to do a line for Fairbanks and one for Key West. So you're basically going to be plotting 3 lines. Make sure you make them different. If you're using the same color, like the same color pencil, make sure that you change them up by maybe making one a straight line, one a dash, and one a dot. And if you have the colored pencils, which you should if you're doing it in lab, just pick 3 different colors and label each one. Tell me which one's which, and then you can start to label up your lines and make them very clean. Don't skip things. Place your stuff on this graph. From there, you go on to answer questions about the graph, and there really isn't much assistance that you're going to need. Be literal. So, for example, question 10, which says, which station has the highest surface temperature? Literally, which station has the highest surface temperature, right? And then they ask you at 10 kilometers, which one has this height. So you go up to the height of 10 kilometers, right? This height here, and you're going to read off which one is warmer. That's all you're doing. Be literal, be clean, write in complete sentences, complete words. Don't abbreviate things, and write cleanly. There's no reason to make sloppy work here. It's a pretty straightforward, easy rest of the lab. It's just answer the question. Nice and clean. No more math equations, nothing tricky. Just clean answering of questions. Thank you. Have a wonderful lab time, and let me know if you have questions. You can send me emails or a text and just contact me about what it is that you're stuck on, and I'll see if I can guide you through it. Best of luck.